Hello YouTube, I am Arend Peter, and today we're going to be talking about how to implement artificial intelligence in GameMaker using state machines. So we're going to go ahead and play what we have so far, and I'll show you what I mean by artificial intelligence, or how far we go with artificial intelligence. So we have this enemy, and he has a variety of behaviors, and the key aspect here, the key artificial intelligence aspect here is that he will adjust his behavior depending on where the player is. So in this case, if I'm in his yellow region, he'll be in the alert, he'll follow the alert behavior, and he'll do his best to kind of follow me. And if I'm in the red region, he sees me, he's going to kind of go run straight towards me. So alert, he's in more of a surveying mode, and in red, he's in a aggressive mode. And if I'm outside the yellow and the red, he doesn't really know where I am, and he just kind of moves randomly. So 3 behaviors, and he dynamically switches between them, making decisions depending on where we are. Alright, so let's go ahead and pull up the base code. Yeah, you can find a link to the base code in the description. I'm going to just walk through it real quick. So I have some sprites. Both of them are centered, and the enemy has 3 sprites to indicate which state. The player has, in the step event, some movement code. This is my compact 4-directional movement code, which takes into account the diagonal uniform speed stuff. I made a tutorial specifically about this code. I'm pretty proud of it, but basically all it does is it keeps track of the 4 directions that you're moving, and there's a link in the description for the tutorial if you want interested in that. That's all for the player. And then in the enemy, in the creation event, we have just some variable declaration. DX, DYs are speeds that we're using in our scripts later. Image speeds, make sure we don't cycle through them. Randomize is nice to make sure the random variables are different each time we play. Okay, then we have 3 scripts. These are the 3 behaviors for the enemy. Now, I'd like to stress that these behaviors don't matter. Like, in your game, you can code the behaviors however you want, and I just threw these ones in and kind of had fun with them as examples. So I just had fun with them, threw some stuff together and whatnot. They're not. You'll probably have your own behaviors for your game, and the core part of this tutorial is switching between the behaviors in an organized fashion. So I'll just go and show them all to you. So we have move random is one of the behaviors. Move random, he just moves kind of in a sort of random fashion. That's what he does with the move random behavior. Then we have move alert. This is supposed to represent where the enemy has a basic idea of where you are, but doesn't really know exactly where you are. So you see it more or less moves in my direction, but if I move around a lot, it sometimes takes a little while to adjust. So it has a basic idea where we are, but it's not moving very fast, and it takes it a while to adjust. That's the alert behavior. And then we have move aggro, which is its aggressive behavior. It sees you and it wants to pummel you. So it's just running towards us, running towards us, running towards us. That's that behavior. Okay. So these aren't important. If you are interested in the code, you can download it and look at it for yourself. I did my best to comment it and use variable names which make sense. So you should be able to read through it, and it should kind of make sense. But for your game, you'll probably want to have your own behaviors, and the key thing is you want to isolate each behavior in its own script like this so we can easily call them. So that's all for that. I'm going to the enemy, and we're going to add some stuff. So the basic idea here is we have basically 2 thresholds. We have the alert threshold and we have the aggressive threshold. So if the player is within a certain distance, it'll become alert, and if it's within another certain distance closer, it'll become aggressive. So let's go ahead and create variables for those so we can refer to them. So we have alert radius, which can be the larger radius. We'll set it to 300, 250. Then we have the aggro radius, the smaller one, represent the radius at which the distance will make the enemy aggressive. That's 150. So we have our 2 radii. And let's go ahead and draw circles with those radii to give us an impression of what's happening. Okay, so I'm going to draw some code for that real quick. Alright, here we are. So I've made these circles somewhat transparent to make it look a little bit nicer. First one's yellow, and it's centered at XY, and it has radius, alert radius. False means it's not an outline. Next one's red, it's going to be smaller, and it has aggro radius. Then I, very gentlemanlike, change the alpha back to 1 to make sure that it doesn't mess with anybody else's drawing code. And then we do draw self to, so we can see us. So let's see how this looks. And there we go. We have our circles, and this is just to give us an idea of how it should work. These circles represent when it should change states, but as you see, it's not doing that just yet. So we could go ahead and stop now and start coding this thing up, but I think it's always, especially working state machines, I think it's always very handy to draw diagrams for this sort of thing. So we're going to go away from GameMaker for a second. We're going to draw a diagram indicating exactly how we want this state machine to operate. Okie doke. So we have 3 states, right? Random, alert, aggro. And in this diagram, we want to indicate when we transition from each state. And we're going to signify a transition with an arrow. So that will represent a transition from the random state to the alert state. In addition to this arrow, we need to have a way to signify what triggers this transition. So with each arrow, I'm going to associate a condition which indicates when this transition will occur. So in this scenario, if we're random, if the enemy's in the random state, and the distance to the player becomes smaller than the alert radius, if the player goes within that outer circle, then it's going to transition from the random state to the alert state. Alright? And then we go ahead and draw arrows for all of the other possible transitions, and we associate conditions with each of those transitions. For the alert state, and the player leaves that alert radius, if it goes outside the yellow circle, then we're going to go back to random. For an alert, and the player gets closer, if we makes it within the aggro radius, it moves to aggro. And then if we're in aggro and the player leaves the aggro circle, i.e. dist is greater than aggro radius, then it moves back to alert. These are all the transitions we need to account for, and oftentimes, especially when you have a lot of states, it won't be exactly clear where there should be transitions and where there shouldn't be. And doing this will give you a good idea of where the transitions are necessary and where they're not. Like a lot of times you want to have transitions between all of the nodes, but in this scenario we don't actually have transitions between random and aggro because, the way these conditions work, it would always go from aggro to alert to random. There's not really a situation where you go straight there unless the player was really fast. But that's kind of a weird scenario. So it might seem a little tedious taking the time to draw this out every time you want to set up a state machine, but especially in bigger games, this is like a must because they can get really complicated otherwise. Here's a state machine that I made for a fighting game. So I had a fighting game for Android, and this was a state machine I used to indicate the AI behavior. And you can imagine that this would have been very difficult to keep track of if I had tried to just do this all in coding logic and not have a formal idea of how the states transition between each other. Alright, so we can move back to the game and let's start coding up this state machine. First thing we need to do, we want to have an easy way to reference all of these states. So I'm going to go to define macros, resources define macros, and I'm going to add these. And apparently I already added them. Well, the way you add them is hit insert, you type out the name, insert the value, and that's it. So just assign 3 values to each of them. Usually we do 0, 1, 2, but you can do whatever. The values actually don't matter at all in this scenario. So I have a state for random, state for alert, state for aggro. Okay. Now jump to enemy and go to the creation event. In the creation event, we're going to add a variable called state, and we're going to start it off at state. We hit control space, select which one, and we're going to start at state random. And then we're going to have another variable, which you'll see why it's here later, and it's called state changed. We start off at false. This will tell us when we've transitioned between a state. All right, hit check. Let's go into set event. So we're going to take that away, and we're going to actually have 3 new scripts, which are going to make up our state machine. So we have check for state change. We have init state, and we have update state. So check for state change will, as it says, it'll check for all of these. It'll see if any of these transitions are necessary. It'll go through all this logic. Init state will handle everything that happens in the beginning of this state. So if we just transition to a new state, there's a lot of times there's some initialization stuff you got to do. So we'll handle that in init state, and then update state is stuff that's happening every frame that needs to be done for that state. The code in here actually represents the update state for all of that. We'll go ahead and create check for state change, and we're gonna have a switch statement. So we got a switch, and we're gonna have switch based off our current state. Remember, state is the variable representing the current state that the enemy is on, and we're going to go through the corresponding transitions. We're going to check for the corresponding transitions depending on the state. So for state random, what do we need to check? Looking at our state machine, if we're in random and we could potentially transition to a different state, which transitions are there? This case, there's only one. There's only one arrow that's leaving random, and that's this one. And the condition there is if dist is less than alert radius. I'm going to actually create dist to player outside of the switch statement because we're going to be using it a lot. Dist to player, and that's going to be equal to the point distance from our position, which is xy, to the player's position, which is oplayer.x and oplayer.y. Brilliant. Okay, so we're going to be referencing that a lot. So we're in state random, and the condition for the state transition is if the dist to player is less than alert radius. If that is the case, then we want to set our state equal to state alert, right? Because that's the state we transition to. And that is everything for the random state. These are all the transitions that we need to account for, just the one. So now we can move over to the next state, and so we can have case state alert. And if we look at our state machine, there's actually two arrows coming out of alert. One signifying that we're going back to random, and another signifying that we're moving over to alert. So let's go ahead and code both those up. If dist to player is greater than alert radius, then we're going to go and set our state equal to state. Let's see, it'll go back to random. Okay, and then we write another state for the other one. If you feel like this makes sense, go ahead and pause the video right here and see if you can finish the state machine. Alright, because at this point it should be feeling a little bit repetitive, or maybe you'll start feeling a little bit repetitive. And that's part of the idea of this particular design. You want to have like extremely consistent pattern of how to handle states and their transitions. Okay, so if you feel comfortable, go ahead and try to finish the rest of it. So the other one is if the player distance is less than the aggro radius, then we want to do state equals state aggro. And then we got a break, and then we handle the last one, which is case state aggro. And for the aggro, that's this arrow right here. Sorry, we're in the aggro, and we have to handle this arrow right here for when the dist becomes greater than the aggro radius. So if dist to player is greater than aggro radius, then we're going to change our state to alert again. Okay, and that is pretty much the majority of the logic in our check for state change. We run through the logic for our particular state, and we check for all of the possible transitions. And just to keep it organized, and you want to keep this script only in charge of changing states. So ideally, you want all these switched cases to only be filled with if statements, and then state change, and then changing of state. Okay. So that way you can clearly see all of your transition logic in here, and you can avoid any issues that can arise from the state transitioning in a way that you don't expect. Alright, so for the next step, for the initialization, we need a way to know whether the state changed. And right now we're just changing it, and that information not going to be available to the state initialization step. So what we're going to do is we're going to create a new variable. Going to call it var old state, set equal to our current state. And then at the bottom, we're going to set our state change depending on whether our old state is equal to our new state. So if the state changed in this code, then old state and state are no longer be equal, and then you'll know if state changed. And then we're going to do this trick, which it's kind of a neat trick, and you probably haven't seen it before. So let's give this a try. So state changed equals state not equal old state. How's that look? I think it's pretty neat. So if you think about it, the other way we could have done this is if state is not equal to the old state, that means that the state has changed. So it would change. Blah, blah. So we would set state changed equal to true if they don't match. If they do match, then state changed is equal to false. So basically what we're saying is if this condition is true, state change is true. If this condition is false, state changed is false. So in that sense, if we're just pretty much setting state change to whatever the condition is, right? If it's true, make it true. If it's false, make it false. Then just skip the if statement and just set state change directly to that condition. That's kind of the idea here, and you see it's a lot shorter and it's exactly the same. Okay, so hope that makes sense. Hope you learned something new there. Next, so we got our check for state changed, and that's most of the logic for as far as the state machine goes. Next, we'll move on to the init state. So I'll create a script, and I'm going to call it init state. So we only want to do this if state is changed. So if the state has not been changed, then we can go and exit. Right? So exit will cancel out of this script, and it'll go back to the caller. So none of this will execute if the state has not been changed. Now we go through a similar switch statement, checking through each of the potential states we can be on. So again, we'll start with state random, and then here we'll put everything we want to do when we initially move to state random. In my scenario, all we really want to do is change the image index equal to 0, which is the frame corresponding to our random state. So that's all you want to do. In your situation, you might have a lot more initialization stuff that you want to do. It just depends. So next we have state alert, and in that case we want to set image index equal to 1. And also, now this is specific to my behavior here. So I have my alert, and the basic logic that happens here is every frame, well, it has a direction first off. This die array represents the direction that the enemy is currently moving. And then every frame, with a certain probability, it either adjusts its direction to be closer to the player or further from the player. When we initially transition to this state, its direction could be anywhere. So just to get it in the right direction, to get it off on the right start, I'm going to go ahead and set direct dire equal to just roughly pointing towards the player. So I'm going to set dire equals direction to player, which is point direction xy o player dot x o player dot y, and then I want to add some random value to it. Random range, we'll have it be -20 to 20. That's all I want to do there. So this just allows my script to start off in roughly the right direction and not be completely running the wrong way. Okay, then the last initialization, which is for case state aggro. In here, we want to set image index equal to 2, and that is all. Later on, we're going to have a similar switch statement like this for the update state, and we're going to be calling these scripts an update state. And just to let you know, we could move these into their own scripts as well. So you can call this like init random, init alert, init aggro, etc. But since they're so small, I decided to just do them in the switch statement. But if they're longer, you would definitely benefit from breaking them into scripts, because they'll be pretty long otherwise. Okay, we're 2/3 of the way there. We have check for state and we have init state. Now we can create one more script. We're going to call this one update state, and we're gonna have one more switch statement in here. So it'll be switch state, and then we gotta do case state random, and then if we're in the random state, we gotta move random. We gotta call that script. And remember, this update state is actually called every single time. Check for change is called every single time, but it only will transition state some of the times. Init state will be called every time, but it'll immediately cancel out if we didn't have a transition. But then this one will be called and executed every single time. So all it is I'm just going through each one of the states we can be in, and I'm calling its script accordingly. Alright, let's go ahead and oh, we got an error. Update state doesn't exist, it says, but I made it here. Well, GameMaker's right, I misspelled it there. Okay, that should be fixed. Now we can test it out, and it should pretty much work. It's following its random behavior, which it should because we're outside of all of its ranges. Moving to the yellow, moving to the yellow, you can tell that the init state executed because its frame changed, but it's unhappy here because it looks like I made a typo in aggregate radius. I misspelled it. Okay, so as the saying goes, or as I like to say, it's errors are nothing to be afraid of. Errors happen very often. Absolutely nothing to worry about. The person who makes it through his entire coding career without causing an error is a person that doesn't exist, frankly. So do not worry about it. Okay, so it's just another typo. Now let's see what happens now. Okay, he's in random. Now he's in the alert, so he knows something's up. And then I go to aggro, he's rushing towards me, and I make it back into alert, and I make it back into aggro, into random. Brilliant, brilliant. Okay, so a couple of, I guess, pointers I'd like to talk about. In your individual behaviors, I think one of the keys is to use a lot of randomness, makes them unpredictable, so that makes it more interesting. But just having these states in here, having being able to dynamically change its behavior depending on where you are, that's what really kind of makes it nice. If you do using a state machine using the standard method, you can implement a state machine fairly easily, regardless of how large it is. So there you go. Let's see. The thing I'd like to talk about next is, let's see, if I'm right at the edge of one of these positions. Oh, let's find a better example. If I'm right at the edge of, let's say, this one, you can see he'll like transition back and forth. Like if I'm right at the edge, see how he'll transition back and forth really fast. And this can cause problems, especially if he has animations involved. That can look really choppy to see him changing back and forth a lot like that. So a good habit is to add some buffers. So for him to change from random over to alert, he shouldn't just be barely over the line. He should be a good deal over the line. So in this case, if it's random and switch to alert, we want to be well within the radius. So we're going to go and subtract 32 from the radius here. So the distance to the player is not only smaller than the radius, it's even smaller than the radius by subtracting 32. Okay, so it has to be well over the line in order to cross it. Similarly here, distance player greater than alert radius, we're going to add 32 there. So not only does the player need to be bigger than the radius, it has to be bigger than the radius plus 32. And then this one we subtract 32. Not only does it need to be smaller than aggregate radius, it has to be smaller than aggregate radius minus another 32. And here we'll add 32 there. So with these thresholds, it's gonna require a little more work for it to jump back and forth. So here I jump in there, and for me to go back and forth like that, it's a lot harder to actually do that. I actually chose 32 because that's half of that's the radius of the player. So now it's not going to switch unless I go completely out of it. So I have to get completely out of it to cancel it, to go back to random, and I have to get completely in it to go back in. So that's a good habit to get into when you're setting for state machine. All right, so we're at about a half hour, or we will be in a couple seconds. So that's all for this tutorial. Thank you so much for watching. I hope you learned something. This isn't the end of state machines. I'm going to make another tutorial where you implement very similar code to make cool animation stuff. So state machines are a very handy tool to have in your toolbox, as it were. Handy trick to have in your toolbox, and we're going to talk about it more. So with that, thank you so much for watching. Leave a comment. Let me know what you thought. I'm always interested to hear what you thought of my tutorials, and also if you used it. I'm always interested to hear how you put in the tutorials to use. And I'm very happy that you watched with me thus far. So with that, I look forward to see you guys next time.